A lot of things that we kind of take for granted you couldn't do without lasers.
It enables the way we use our mobile phones. It enables the internet.
Our mission at M² is really to use precision light for good. 50 of the 100 indicators of climate change need precision light to measure them. In life sciences, to create new treatments and therapies for disease. We want to do things that improve the world. SolsTiS is a titanium sapphire laser. Our eyes see in the visible area of the optical spectrum that goes from the reds to the blue, but the spectrum is actually much broader. It goes all the way down into the ultraviolet and all the way up into the far infrared. SolsTiS is a laser that can cover that whole range.
This light is 10,000 times more pure than the average laser. Purity is a bit like the sharpness of a surgeon's scalpel, and you compare the tunability of the laser and its derivatives to a loaf of bread. It's like we're able to cut the loaf of bread into 100 million slices.
The things that set SolsTiS apart from existing laser systems are that it was done to such precision and accuracy. It transferred what would have been a physics lab into a box that you can hold in your hand.
Historically, lasers have been very much a hands-on affair, but this is completely automated.
Inside the laser, there's a titanium sapphire crystal. It's a very small crystal, it's millimeters, and it's quite difficult to get the heat out of such a small space, and that's partly the secret of how it's so efficient. In order to make everything so miniature, we had to just start with a clean sheet. Nothing is off the shelf. Everything is designed optomechanically from scratch.
The thing that made the SolsTiS platform so outstanding from the judge's standpoint was the fact that it has a multiplicity of applications.
SolsTiS is the only laser system in the world to calibrate satellites that go into space. And using these Earth observation satellites, we can accurately locate and identify sources of pollution. Quantum is a really new technological field that has the potential to replace the digital era.
My group at Imperial College, together with M², has built this quantum accelerometer. A quantum accelerometer is a device to measure acceleration. In navigation, it's possible to navigate without needing to communicate with the global satellite. Because of the purity of the light is used to read out the quantum state of the atom to tell us what the acceleration is. We have to be able to jump the light from one color to another very quickly and very accurately. There is no other commercial system available to do this.
Over the years, we've now sold more than £50 million worth of SolsTiS lasers. We're really excited to see it move into more industrial applications. It's unlocking technology capabilities that nobody could have imagined, and SolsTiS is really right at the middle of that and really enabling that.